All right, 6.3 notes, essential question. How do you find the composition of functions such as f of g of x? We'll talk about composition of functions. Probably haven't done this before. Operations of functions. Let f and g be any two functions. A new function h can be defined by performing any of the four basic functions. So basically, if you have two functions, f of x and g of x, you can add them, subtract them, multiply them, and divide. Okay. They give you some examples over there, and we'll practice some. The domain of h consists of the x values are the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x equals 0. Okay, so basically, we just got to take into account domains that restrict the functions. We won't get much into that, but we'll talk about that a little bit as we go along. So the first one says, example 1, let f of x equal 3x minus 8 and g of x equals 2x squared. Find the following. So f of x plus g of x, we just write, would be 3x minus 8 plus 2x squared. Well, if they were like terms, we would combine like terms, but there are no like terms on this one, so we're just going to rewrite the standard form as 2x squared plus 3x minus 8. And that'd be our answer. Okay, we added f of x and added g of x. That's all we have to do. G of x minus f of x is pretty much the same thing. We got 2x squared minus 2x squared minus 3x minus 8. Okay. Again, the main thing I like to do is when I have a minus, I have parentheses, and I always want to write it as parentheses if there's more than one term, is distribute that negative. So you'd have 2x squared minus 3x plus 8. Okay, and then that would be your answer. I know it might look a little bit on my notes. It says f of x minus g of x, and this it says g of x minus f of x. So you can do that problem as well, but that's how you would do this one with this notes. Okay, so I understand notes might not line up perfectly, but you get the picture. Okay. Okay, then you do f of x over g of x, so you do 3x minus 8 over 2x squared. Now, you probably could split those apart and simplify a little bit more, but they all do not have one common factor. They all don't have an x, they all don't have 3, 8, and 2 have no common factor. So I think it's okay to just leave it like this and be done. Okay. Then the next one, we have f of x times g of x, so we got 3x minus 8 times 2x squared. Okay, so all we're going to do is distribute the 2x squared to both parts. 2x squared times 3x is 6x cubed, and 2x squared times negative 8 is negative 16x squared, and that's as far as we can simplify it, so we're going to leave it like that. Okay, so that's adding, subtracting, multiplying, dividing functions so far. Now we're going to start doing some composition functions. So it says the first one, you got f of x, you got g of x. The first one says find the following when g is negative 3. So we're going to write g of negative 3 equals, we're going to plug in negative 3 for x, negative 3 squared minus 1. Always plug in parentheses when you plug in a number. So we have g of negative 3 equals 9 minus 1. Okay, and 9 minus 1 is 8. Okay, so g of negative 3 equals 8. Now, if you look at the other one, it says f, how you read that and on B is f of g of negative 3. Okay, well, we already know what g of negative 3 is, right? G of negative 3 equals 8. Okay, so what I can do is plug in 8 for g of negative 3 and just make it f of 8. So that's what I'm going to do here. Since I already know that g of negative 3 equals 8, I can do f of 8. Okay, f of 8 equals 3 times 8 minus 4, which gives us 24 minus 4, which gives us 20. So if I wrote it all out at the end, because I know that g of negative 3 equals 8 and f of 8 equals 20, then I know that the original problem, f of g of -3 equals 20. Okay? That might take some practice. But the main fact you have to have is g of -3 equals 8. Then I'm doing f of, instead of f of, basically it's usually f of x, now I'm doing f of g of -3, which I already know is 8. So I just replace the x with 8. Okay, going a little bit further. Okay, so now we have, it says f of x is 3x minus 4, g of x squared minus 1. So it says g of f of 2. Okay, so f of 2 is going to go first. Okay, so this is f of x. So if I have f of 2, then I'm going to have, 3 times 2 minus 4. Okay, 3 times 2 minus 4. Okay, which gives me 6 minus 4, which gives me 2. Okay, so if I know that f of 2 is 2, then I can replace f of 2 with 2. So I can pretty much just replace this with this. Okay, so instead of g of f of 2, I can just do g of 2. So g of 2, would be, g of 2 would be 2 squared minus 1, because I'm plugging in 2 for x. So 2 squared minus 1 is 4 minus 1, g, and 4 minus 1 is 3. Okay, so if I really wanted to write my whole answer at the beginning, what it would be g of f of 2, g of f of 2 on x equals 3. Okay. Because we know in f of 2 is 2, and then when you plug in 2 for x in the other equation, you get 3. Okay, so g of f of 2 is 3. And that's how you would solve that. And there's other ways you can solve that too, but I think that's the best way. Okay, now in D it says, it doesn't really want you to solve, it just wants you to rewrite the function. So you have f of g of x, which means you're going to do g of x first, then you're going to do f of x. Or basically what that means is you got to plug in g of x in for the x in the other equation. So usually it's f of x, now it's f of g of x. So that means I have to plug in x squared minus 1, which is all of g of x, and for x in the other equation, okay? Because usually it's just f of x, you plug into the x, now we're plugging in the whole equation in for x. So how it's going to look is f of g of x equals 3, parentheses. Now I'm going to plug in my x squared minus 1 minus 4, okay? And then if it's easy to simplify, you can. If it's not, then don't. But this one's pretty easy to simplify, so we're going to do that. So we got f of g of x equals 3x squared minus 3 minus 4. Then you can combine my terms. F of g of x equals 3x squared minus 7. And that would be your answer. Okay. So that's how you do composition functions. F of g of x, something you have to be able to do. Basically, the inside function, the g of x, you're going to plug into the x in the other equation. Okay, and rewrite it that way. Okay, it says you have a $10 gift card to a paint store. Store is offering 15% of any purchase of any paints and painting supplies. You decide to purchase a $30 can of paint and $25 worth of painting supplies. Okay. Find the sale price you purchased when the gift card is applied before the 15% discount. All right, so first thing we're going to do is find out, you bought $30 can of paint and $20 worth of painting supplies. So you add those together. Your total amount you spent is $55. Okay, but we're going to leave that till the end. All right. First, it says find the sale price. Well, let's write a function for a $10 gift card, okay? And let's call that f of x. So if you have a $10 gift card, the price you're going to spend, which we know is $55, but right now I'm just going to call it x. It's going to be the price you spend minus $10, okay? That's going to be f of x. If you just spend, you get $10 off whatever you spend, okay? The other function is you get 15% off. Well, let me write that as g of x equals whatever I spend minus 15%, which is 0.15 as a decimal, of what I spend, okay? 15% off of what I spend. So I subtract 15% of wherever the price is, okay? Or, if we think about it this way, 1x, or 100% of x, minus 15% of x, or minus 0.15, is going to be 0.85x, okay? So that's the second function. If I'm taking 15% off something, I'm paying for 85% of it, which is 0.85%. So I'm taking 0.85 times whatever I spend to get that. So it says, find the sale price of your purchase when the gift card is applied before the 15% discount. So if I want to apply the gift card first, I'm going to write that on the inside, okay? So how that would look is as a composition function. And again, you could probably solve this without doing composition functions, but we're just practicing what we're using, so that's why we're doing this. You would want to write it as g of f of x, because whatever you use first, you want to put on the inside. So if you're going to use the $10 off first, you want to put f of x on the inside. So what we're going to do is write that. We wrote g of f of x, we're going to plug in x minus 10 and for here right here. Or plug it in for the x and the other one, the g of x. So it would be 0.85 times x minus 10. Okay? Which we could just leave it like that for right now. All right? Actually, we could plug in, well, let's just leave it like that and we'll write it out. Okay? The other one says find the sale price when the 15% discount is applied before the $10 gift card. Okay, so if you do the 15% first, that means you're doing g of x first, so you want that in the inside. So then you want f of g of x, which would be, you plug this, g of x, which is 0.85x, in for x in the other equation. So it would be 0.85 x minus 10, okay? Looks similar, but there's a subtle difference between the two. So now we can plug in 55 and see which one's cheaper, okay? So if we plug this in, plug in 55 for x, we'd have 0.85 times 50, was it 55? Yeah, 55 minus 10, okay? 0.85 times 55 is 46.75 minus 10 gives you $36.75. Okay, so if you take the discount for 15% off, then you take the 10, then you use your $10 gift card, you use $36.75. Let's see if you do it the other way. You got 0.85, you got 55 minus 10, which 55 minus 10 is 45. And then when you multiply those together, you get $38.25. Okay, so it's cheaper to do the discount, the 15% off first, and then do a $10 gift card, which makes sense, right? Because you always want to take, if you spend a bigger amount, when you get a percent off of that, then it's going to mean you get a bigger percent off the price, okay? If you spend a smaller amount, which if you take $10 off, you spend a smaller amount, then you're going to take 15% off a smaller number, which is not going to be as much, okay? But that's just how you apply composition function on that. Okay, there's your exit slip, and that is it.